Welcome back. Today we are putting on our chef's hats and stepping into the kitchen of artificial intelligence. We're going to follow a step-by-step recipe, for real, to teach a computer how to understand one of the most basic things about language, grammar. So, let's get cooking. So it all boils down to this, right? How does a machine, a thing that only thinks in ones and zeros, learn the difference between a noun and a verb? You and I, we just know that dog is a thing and run is an action. But how do you teach that kind of intuition? Well, that's the puzzle we're going to solve today. The secret sauce here is something called part-of-speech tagging, or just POS tagging for short, and it is exactly what it sounds like. We're going to take a sentence and literally attach a label or a tag to every single word, telling the computer if it's a noun, a verb, an adjective, you name it. This is the absolute first step for a computer to start seeing the structure of our language.
And yeah, this whole process, this POS tagging, it's the foundation for everything we're about to build. It's like we're teaching our AI the alphabet before we ask it to write a novel.
Okay, step one, like any good recipe, it all starts with gathering your ingredients. You can't just whip up a world-class AI model out of thin air. You need top-notch, high-quality materials to work with. So, what's on our shopping list? We need two main things. First up, the main course, the corpus. Think of this as our raw text. In this case, we're using something called the AnCora corpus, which is a huge collection of over 14,000 sentences from Spanish newspapers. But that's not enough. We also need some seasoning. This comes in the form of word embeddings. Now this part is super cool. We're using a set called Glove, which is basically a pre-made dictionary of over 850,000 Spanish words that already understands the relationships between them. It's like giving our model a giant head start on learning the language. All right, we've got our ingredients. But, you know, just like you wouldn't just chuck a whole carrot into a soup, we can't just dump this raw data into our model. We got to do some prep work to get everything cleaned up and ready. And this is all about making things consistent. First, we standardize every word. We make them all lowercase, so cat and cat look the same to the machine. We also turn any number, it doesn't matter how big, into a simple 0. Next, we add a special little thing called a pad token. We'll see why that's important in a minute. And finally, the most important step of all, we turn everything into numbers. Every single word, every grammar tag gets its own unique ID. Because at the end of the day, computers don't speak Spanish, they speak math. With all our ingredients prepped and ready, it is time for the main event, building the brain of our operation. This is the neural network that's going to do the actual work, the cooking, and figure out how to assign all those grammar tags. So let's see how it's built, layer by layer.
So the first layer that our data hits is the embedding layer. You can think of it like a receptionist. It takes the numerical ID for a word, looks it up in that giant glove dictionary we gave it, and pulls out the rich, complex meaning of that word. It basically turns a simple number back into a meaningful idea for the model to work with.
Next up is the real powerhouse of our model, the LSTM. That stands for long short-term memory. This thing is so cool. It reads the sentence one word at a time, just like we do. But its superpower is memory. It actually remembers the words that came before it, which is absolutely critical for understanding grammar. I mean, think about it. The word running means something totally different if the word was came right before it, right? The LSTM gets that. And finally, once the LSTM has gone through the whole sentence and figured out all the context, it passes its work along to the last layer, the classifier. This is the decision maker. It looks at everything the LSTM learned about each word and makes the final call, slapping on the most probable grammatical tag, noun, verb, adjective, whatever it might be. Now, here's a really neat little professional chef's trick to make this whole thing run better. Remember those pad tokens we added to make all the sentences the same length? Well, it's a huge waste of time and energy for the model to analyze those empty spots. So we use a technique called packing padded sequences. It's a fancy name, but all it means is we tell the model, hey, just ignore all that padding. Focus only on the real words. It's a simple move that makes the model way faster without losing any accuracy. It's a total game changer. Okay, the recipe is complete, the model is built, it's been trained, now comes the moment of truth. How did our dish turn out? It is time for the taste test, where we see if this thing can actually identify grammar in sentences it's never seen before. And the result? A whopping 97% accuracy. Let that sink in. Out of every 100 words the model was tested on, it got 97 of them right. That's fantastic. It's an incredible score that puts this model right up there with the best of the best, with state-of-the-art approaches. But, you know, that big number doesn't tell the whole story.
When you really dig into the details, you see some interesting things. For example, it's a total rock star at identifying determiners, words like el or un in Spanish. It gets those right 100% of the time. It's also super solid with nouns at 96%. But, and this is a big but, look at the bottom row. It really struggles with symbols, only getting them right about 38% of the time. And that's a huge lesson. Even a model that's 97% accurate has its own specific strengths and, well, blind spots.
So, we've walked through the whole recipe, we've seen the results, but let's zoom out. What's the big picture here? Why does following this one little recipe even matter in the grand scheme of AI?
Well, there are a few key takeaways. First, building AI isn't some kind of dark magic. It's a logical process with repeatable steps, just like a recipe. Second, starting with pre-trained knowledge, like those word embeddings, is an unbelievable shortcut. It gives the AI a massive head start. Third, those little efficiency tricks, they're not just nice to have, they are absolutely essential to make these powerful models practical for real-world use. And finally, no AI is perfect. The real key is knowing what it's good at and what it's bad at, so you can use it effectively.
And that brings us to the end. We've seen how a machine can follow a recipe to master the rules of grammar with, frankly, stunning accuracy. Which leaves us with one final pretty exciting question. Now that AI has the foundation of grammar down, what's the next part of language it's going to learn? Sarcasm? Emotion? Maybe even creative writing? The recipe book is wide open. Thanks for joining me.